Hi there, in this new clip in the C# for Beginners series, we'll talk about constants as a continuation of the topic of immutability, of which I keep talking about for a few lessons. The main property of constants, as their name suggests, is that once declared, they can no longer be modified, thus remaining constant. And there are generally two types of constants. Constants which have their value declared during the compilation, also known as compile time constants, and runtime constants which have their value declared during the runtime. Sadly, for runtime constants, C# has no general equivalent for the C++ const object and const init, and read-only only partially approximates some of that behavior. Same for the read-only ref. But we'll learn about read-only in the next lesson and we'll see the details of it. To take an example, let's declare a very known constant, the rough value of pi. So as you can see, by simply placing the const keyword, we tell the compiler that this value will never change. And please don't call this a variable, because I've seen people call them constant variables. That's an oxymoron, it's a contradiction in terms. You should also know that while the official Microsoft recommendation is to use Pascal casing for constants, so just like properties, to have each word capitalized, there is a strong tradition in other languages to have constants named with all uppercase letters separated by underscore. And at least for me, that makes much more sense, because I do want to be explicit. I do want to immediately see when something is a constant and not a regular property. One first thing about constants is that they are static by default, even though they don't specify a static keyword. In fact, the compiler will even forbid its usage in the declaration. A constant can also be any kind of expression that can be evaluated at compile time. So, since, as we surely remember from math classes, the value of pi can be approximated by the division of the numbers 22 and 7. And also, since constants are constant, we cannot modify or assign them in any other place or time other than their declaration. So this will generate a compiler error. A const field requires a value to be provided. We cannot initialize it any other place other than its declaration point. So that's pretty much the entire idea behind compile time constants. But for those of you that might feel adventurous, you might encounter a strange behavior. And do note this is a bit advanced, so it's not intended for you as a beginner to understand the mechanics behind it. But if it does feel complicated, don't fret your teeth. It's okay, it's not intended for beginners. Let's say we want to create a color class using the RGB model, where each color is expressed as a combination of three separate values, red, green, and blue, expressed as integer values between 0 and 255, where complete black would be 000 and complete white would be 255 for all three channels. So we could have something like this. Where we have three separate properties and a constructor where we ask for three mandatory parameters and we assign their values to these properties. And let's say that some colors are more often used than others, like for example red, where we have the red channel 255 and 00 for the green and blue. Let's say we want to offer that as a constant for the users of our class, so then don't have to recreate it every single time with potential errors. So we could do this. And we already have an error. The expression being assigned to color.red must be a constant. This happens because, like I said, const only accepts constant expressions to be assigned to it. So by the time we compile our program, the value of that expression should be already known, should be evaluated so it can be assigned. But new only creates this instance, only allocates the heap memory and so on when the execution gets here. So by the time the program runs, after we click start, not by the compile time, which of course it cannot be assigned to a const. And in fact, any reference type with the exception of constant, strings and null is not possible to be assigned to a const. So we cannot use new first of all with the const keyword, because new only gets evaluated at runtime. Next, for any user-defined reference types, we can only assign null. So you cannot never assign to a const a non-null reference type. We will learn how to deal with this in the next lesson with the help of static read-only fields. Anyway, you should also know that we can also declare const inside methods, so they are not necessary to be fields. You may ask yourself, what is the use of a value you can never change? Well, first of all, to express values that never change. Like for example, if we have something like this, is 100 having a special meaning, or is just a coincidental accidental value? No idea. But if we express it like this, it makes much more sense and it's much more obvious what 100 means. And it also doesn't change because the boiling temperature of water never changes. Anyway, that was all I had for you for this lesson. And don't forget to like and subscribe if you woke up on the right side of the bed this morning. And until next time, thanks for watching and I'll see you in the next tech frame.